Alright, Suhu, this problem, we got how many different license plates are possible if 2 digits are followed by 3 letters? So the way we're going to set this up is the first 2 digits right here. There's only 10 numbers, so we're going to have 10, 10, and there's 26 letters in the alphabet, so we will put 26 right here, and we just multiply all these together and we get our big answer of 1,757,600. That's how many possible ways you can make a license plate.
Yeah, Bupe!
Alright, so for this problem we're going to find out the number of possibilities there are for creating custom Nike free runners. Alright, so you have to take into part to how many different colors there are for each thing. So for the upper part of the shoe, you know, the mesh, swoosh, lace, mid-side rim, and tongue. So with all of these numbers represent the different colors that you could use for the shoe. So to find out how many possibilities or different combinations you have to multiply all the numbers together, and when you multiply all the numbers together you get 103,574,016, and that's how many different combinations you could do, or that's how many different times you could customize your own Nike free runners. There you go. That's how you do that.
Hey Mr. Suhu, this is Colby, and I'm going to show you how to do permutations and combinations. And so the difference between those two is that in a permutation problem, order matters, and it's usually in a list. In like the question, it's usually in a form of a list. And combinations, order doesn't matter, and it's usually like a group in a question. So pretty much what you do for permutations is, say you're given a problem like that, 7p6. So now what you do, this is like the formula that you would use. So you bring the 7 right here, you take the 7 and the 6 and put them right here and put them in the minus. And you pretty much just simplify it and you get 7 over 1. Now what this means right here is that you have to multiply all these in a row from 7 all the way to 1. So what you do is you do 7, 6, 5, 4, 3, 2, 1, and then you put a 1 on bottom because that's what's left, and you just cross out common numbers, and then you're left with this, and you pretty much just multiply that together, and that's how many different ways you could make that list, like if that's part of the question. So that would be your answer for a permutation. Now combination, alright, wait, it looks the same, but it's not, because what you do for your formula right here, you do exactly the same right here with the 8 on top, but now you bring this number, put it on the side as well with this, and you simplify that and you just put it in order just like that, but this way you will have 2 terms, so you have to write both of them out because there's 2 different right there. So you do 4 3 2 1, 4 3 2 1, and you only cross out 1 set of numbers for common like variables, I would say, and you multiply them out and you get 3,640 over 24, and you simplify that to 455 out of 6. And that's how you do permutations and combinations.
In the table below, write the sum that would result each roll. Would this sample space make you more or less likely to play craps, and why? So Suhu, when I go to Vegas, it's probably my favorite game because I have better odds playing this and I don't get ripped off as much. So in this one, my probability of winning is rolling 7 or rolling 11. So that would be 6 over 36 plus 6 over 36, which would be 8 over 36, and 2 over 9. So the percentage is 22.2 of winning. My percentage of losing would be if I roll 2, roll 3, or roll 12. And here's the work, and my percentage of losing would be 11.1%.
Burgers are ready.
Yeah.
Alright.
Alright, Suhu. Shadid throws a dice and spins a coin 150 times as part of an experiment. On 71 occasions, the coins land heads up. On 21 occasions, he rolls a 6. On 68 occasions, he gets neither a head or a 6. So this is a table that I was able to make out of the problem. As you can see, the red numbers are the numbers that were given to me, and I was able to figure out the green ones through figuring, like doing math and stuff. Okay, now from this data table, I was able to find out that the probability of me rolling a 6 is 7 out of 50. That's the probability of me able to roll a 6. Now the probability of me rolling a 6 giving a head is 10 out of 71. Now from this data table, rolling a 6 or flipping a head, and like it's independent because one does not affect the other one. And this is your dice, the table problem.
I don't know. Here's the wash code in the car.
Alright.